Welcome to The Explainer. I am so incredibly excited to have you here today because we are going to completely revolutionize how you tackle your exams. I want you to do something for me right now. Completely shift your mindset. I need you to stop treating your Cambridge mathematics exam like a simple, traditional test of memory. Instead, I want you to treat this examination paper exactly like a high-stakes, high-pressure trading floor. Imagine you are standing right in the middle of it. The clock is ticking, the pressure's on, and in coordinate geometry, specifically when you are solving multi-stage problems involving lines and circles, your time is your capital. You are the lead trader here, and you need to invest your time where the marks, your return on investment, are the absolute highest. It's all about split-second decisions. And look, it doesn't matter where you are in your math journey right now, whether you are building those crucial foundational skills in the 0580 syllabus, or maybe you're pushing into additional math with 0606 and 4037, perhaps you're navigating the specific nuances of 4024 and 4040, or you are stepping all the way up to the big leagues of the AS and A-level 9709 syllabus, and even further math 9231. The core underlying strategy remains exactly the same across the board. You must make calculated, strategic decisions that guarantee the highest possible yield for every minute you spend writing. We are going to decode exactly how to do that today.
That brings us perfectly to this powerful, almost shocking insight straight from a senior Cambridge examiner. I really want you to notice the examiner's specific emphasis on the word easy here. Easy marks. Now, you might be thinking, coordinate geometry? Easy? But let's break it down. When we deal with lines and circles, the fundamental equations are actually pretty straightforward, right? You already know that y equals mx plus c. You know the circle equation, x minus a squared plus y minus b squared equals r squared. You've memorized these. The raw mathematical facts are rarely the actual issue for students. The real issue, the trap that catches so many brilliant students, is how candidates structure their multi-stage analysis when they are under intense exam pressure. It's about what happens when you have to combine three different rules into one seamless argument. But don't worry, because I am going to pull back the curtain and show you exactly what these examiners are actively looking for. And we are going to turn those previously lost opportunities into absolutely guaranteed points on your paper.
So here is our blueprint for today's session. First, we'll uncover the mark-losing trap. Second, we'll build the procedural framework. Third, we'll master the method mark strategy. Fourth, we'll dive into an interactive workshop. And finally, we'll cover examiner warnings and critical analysis. Let's get straight into it. Section 1. The mark-losing trap. Let's look at where things go wrong.
Act 1 of our journey begins right here on our metaphorical trading floor. Picture this scenario. You flip the page, and the clock is ticking down on a massive 6-mark question. It's asking you to find the exact coordinates of intersection between a complex, unexpanded circle equation and a linear equation. Panic often sets in immediately. So, why do students find this kind of multi-stage analysis so incredibly hard? I'll tell you right now, it is not because the algebra itself is impossible. It is because multi-stage problems require a sustained, unbroken chain of logic. Think of it like a delicate chain. One dropped negative sign, one tiny failure to substitute a value correctly in step 2, and your final answer at step 5 is completely gone. But here is the secret the top 1% know. The final answer isn't the only thing that matters. The true difficulty lies in translating a visual, geometric concept into a rigorous algebraic procedure without losing the narrative thread of what the question actually commanded you to do in the first place. You have to tell a mathematical story.
Let's make this concrete by looking at two very typical candidates. This perfectly illustrates the two extremes of how students fall right into the examiner's trap. On the left side, we have Alex. Now, Alex is the classic over-investor. Alex overloads the page with raw mathematical facts. Faced with a circle geometry question, Alex panics and writes down the distance formula, the midpoint formula, the gradient formula, and the general equation of a circle, just hoping and praying the examiner will pick out the right one from the mess. There is zero structural analysis happening, it's just an information dump. You can practically see the red pen marks crossing it all out. Now, on the right, we have Sam. Sam is the opposite. Sam is quick, super fast with mental math, but Sam rushes madly to the finish line, completely missing the command word requirements. If the question explicitly says, show that the line is a tangent to the circle, Sam just quickly calculates the discriminant, writes down equals 0, and moves on to the next page without ever writing the concluding analytical statement that actually secures that final crucial mark. Alex overinvests without structure, Sam underinvests and leaves guaranteed points sitting on the table. We need to find the sweet spot between them.
Section 2. The procedural framework. Here is how we fix it.
To really master this, we have to look at the specific assessment objectives the syllabus targets. They are looking at distinct cognitive domains, and they heavily prioritize analytical depth over superficial breadth. Knowledge and understanding, that's just your baseline. Do you know the formulas? Great, but that only gets you so far. The real heavy-hitting marks are found in application and analysis. This is where I want to introduce a game-changing tool. We're going to take a framework usually used in humanities essays called the Peel framework, and we are going to apply it directly to high-level mathematics. Peel stands for point, evidence, explanation, and link. How does this work in math? Well, in coordinate geometry, your point is identifying the core geometric principle. For example, explicitly stating the radius meets the tangent at 90 degrees. Your evidence is the raw mathematical data you extract from the prompt, the specific coordinates given. Your explanation is your step-by-step, flawless algebraic working. And finally, your link is tying your final numerical value directly back to the specific command word in the question. Top students use this exact structured reasoning to create completely bulletproof answers.
So practically, how do we deploy this framework under pressure? It comes down to following these 5 sequential steps on exam day. Step 1, deconstruct the question. You must decode the command words. Are they asking you to find, show that, derive, or hence? Step 2, extract the relevant data. Pull out the coordinates, the gradients, the equations, and write them clearly at the top of your workspace. Step 3, select your analytical framework. Are you going to use the discriminant to prove intersection, or are you going to complete the square to locate a circle center? Make a definitive choice. Step 4, execute using the Peel method with absolutely clear, unambiguous notation. And Step 5, present your final answer precisely as requested. If they ask for exact third form, do not give them a decimal. If they ask for 3 significant figures, give them exactly that. It's about total precision from start to finish.
Now, getting this framework down requires practice and the right resources. So before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. We share deep dives into these exact frameworks all the time, and you definitely don't want to miss out on building your exam arsenal. Section 3, Method, Mark, Strategy. This is the holy grail of exam technique.
Listen closely, because examiners issue a major recurring alert in their reports every single year about candidates not showing their working. Investing time in documenting your process is your absolute safety net. We call this the method mark strategy. In Cambridge examinations, especially in those nasty multi-stage coordinate geometry problems, the final accuracy mark, the A mark, often depends on a really long chain of preceding calculations. If you make one tiny arithmetic slip in step 1, your final answer will mathematically be wrong. But if you clearly document your mathematical Peel framework, showing the examiner the correct substitution into the correct formula at every stage, you will secure the method marks. Those M marks are your insurance policy on this trading floor. Never ever do complex mental arithmetic and just magically write down the answer. If you get it wrong, you lose everything. Document the process, show your logic, and bank those method marks, even if your calculator slips.
Seriously, mastering this specific method mark strategy is the difference between an average grade and a top-tier grade. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4, Interactive Workshop. Let's put this into action.
All right, it's time to test your split-second decision-making. Imagine we are running a 60-second data scan challenge. I want you to picture a complex data table or a tricky coordinate geometry graph right in front of you. The clock starts now. You have 60 seconds to extract the core trend. You need to identify limitations. Is the domain restricted? You need to question assumptions. Don't just assume a random line segment is a diameter just because it happens to pass through the circle. You must algebraically prove it passes through the center. Now imagine a flawed paragraph written by our friend Sam. You have to find the flaw. Consider alternative interpretations. If you calculate 2 potential values for a circle's radius and one is a negative number, what is the effect on your conclusion? A geometric length literally cannot be negative, so you must explicitly state that you are rejecting the negative root to secure that final mark. Finally, in a 30-second speed writing challenge, you'd need to write out one perfect Peel paragraph defending that choice. This kind of rapid evaluative thinking under pressure is what truly separates an A from an A star. It's about anticipating the traps before you even pick up your pen.
Section 5, Examiner Warnings and Critical Analysis. Let's look at the red flags.
When you read through years and years of principal examiner reports, a pattern emerges. There are exactly 3 major catastrophic mistakes highlighted repeatedly for coordinate geometry involving lines and circles. If you can systematically eliminate these 3 errors from your exam routine, your mark potential instantly shoots straight toward 100%.
To make sure you never make these mistakes, I want you to memorize a simple hack. It's a mnemonic using the first letters of the key terms, the CFA rule: cause, format, and answer context. Mistake number 1. Examiners report that students constantly confuse cause and effect in their geometric reasoning. Mistake number 2. Students completely forget to double-check the required format and presentation. Imagine doing an entire page of perfect algebra and leaving your final equation full of messy fractions when the command word explicitly demanded integers. You lose the mark. And mistake number 3. Answers are not specific to the context given. If a coordinate geometry problem is modeling a real-world scenario, like a physical boundary or a map, a negative coordinate might be completely nonsensical in that context. You have to tie your math back to reality.
Let's really drill down into that first mistake, because top-scoring candidates absolutely never confuse these two. They use what we call comparative connectives to map out their reasoning. Let's break down cause versus effect. The cause is the fundamental underlying geometric principle. For example, stating, the radius is perpendicular to the tangent at the point of contact. That is the geometric truth. The effect is the mathematical execution of that truth. Therefore, the product of their gradients is -1. So many students just write down m1 times m2 equals -1, without ever stating the geometric principle first. If you do that, you are showing the effect without the cause. By linking our Peel framework here, stating your point, which is the cause, before showing your evidence and explanation, which is the effect, you demonstrate total, undeniable mastery to the examiner.
Mastering this kind of comparative analysis requires you to confidently check all 4 of these boxes to prove your practical application skills. If a question asks you to analyze the relationship between 2 circles, say determining if they intersect twice, touch externally, or are entirely separate from each other, you must identify similarities and differences in their properties. You need to use comparative connectives in your final written statements like whereas, therefore, or consequently. You must support every single theoretical claim with hard, undeniable mathematical evidence. Those are your method marks in action. And finally, you must draw definitive conclusions. Mathematics at this level isn't just about blindly crunching numbers in a calculator. It is about logical, structured, and profoundly evidence-based reasoning. This is exactly how you invest your time in the analytical frameworks that the examiners are desperately searching for.
Implementing these exact systems, decoding command words, applying the Peel framework, and managing your time matrix is exactly what shifts grade boundaries. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Now, I want to hear from you. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing with coordinate geometry. Are you struggling with method marks or maybe finding the cause and effect? Let me know. Our team responds to every comment. Like and share this explainer with a study partner to make sure you both crush it. Ace the Exams, your Cambridge success starts here. See you in the next one.